Welcome to this demonstration on how Atom works. For this, we are going to use the SockShop application. It is an e-commerce application. You can see its products via its catalog. You can add the item to the cart if you want. You can go to see your cart or even delete the item. So, first let's look at the microservices behind the SockShop application. As you can see, these are all the microservices deployed having a single replica. Next, we're going to start the components of Atom. First, the scaling command executors. Next, the analysis engine that will analyze the data and provide the optimal scaling configuration. The engine will analyze the data based on the LQN model, which has different parameters like the host demand mean and the call mean. We will also need the scaling server that will orchestrate these components. So let's start the load test. For load test, we are using the locus tool. Here, we need to provide the number of users we want and their spawning rate. So if we start swarming, we will gradually see the number of users increasing and they start to send requests corresponding to different features. Once we finish spawning all the users, we can see the system throughput, which is pretty low, around 70 transactions per second. In the meantime, we have started the monitoring agent, which is periodically collecting the request statistics per feature. We have defined a monitoring window, and after each monitoring window, it sends the data to the scaling server that again passes it to the analysis engine. The analysis engine starts to search for the CPU share and the number of replicas for the concerned microservices that will optimize the transactions per second. As you will see below, it will provide the CPU share for 6 microservices and the number of replicas for 3 microservices that can be scaled horizontally. These configurations are translated into scaling commands and run by the executors. After that, we will notice that the transactions per second starts to improve. From a value around 70, the transactions per second quickly crosses the 300 mark. It increases for a while and then it stabilizes around a value just above 400. In the meantime, the analysis engine continues to work based on the data it periodically receives, and as you can see, it further reduces the CPU shares for the same workload. Even though we can see that the transactions per second remains stable. The average response time also keeps dropping, which initially was 35 seconds is now around 3 seconds. After some time, we have reduced the workload. You can see that from the chart as the transactions per second value starts dropping. Atom observes this workload change and suggests a much lower CPU configuration. We can see that even with that low CPU configuration value, the transactions per second still remains stable.